Okay, so on to the next part. We're going to answer the following as indicated. So find the dimensions of a rectangle if the perimeter is 23 inches and the area is 30.66 inches. So if the perimeter is 23, then 2 times the length plus the width, or 2L plus 2W, will equal the perimeter, which here is 23. And the length times width, or the area, is 30.66. So what I'm going to do here is solve for one of the variables. It does not matter which one. So I'm going to pick W. So W will equal 30.66 divided by L. Now that I know that W equals this, I'm going to substitute it back in for this W. So I'm going to have, I'm going to substitute that in for W, but at the same time, let's go ahead and divide both sides by 2. So I'll have L plus my W, which is 30.66 over L, and then 23, dividing that over 23 divided by 2 is 11.5. And then to get this L out of the denominator, I'm going to multiply every single thing by L. So I'll have L squared plus 30.66 equals 11.5L. And then if I put that into a quadratic, standard form of a quadratic, then I'll have L squared minus 11.5L plus 30.66 equals 0. Now I can just plug this in to the quadratic formula, and we'll get L equals negative b, so 11.5 plus or minus the square root of 11.5 squared, so 132.25. So there's b squared minus 4 times a, which is 1, times c, which is 30.66, all over 2 times a, which is 1. So we'll get L equals, whenever we solve for that, we'll get 7.3 or 4.2. And that may concern you, because then you think, well, do I have two different sets of dimensions that work here? But if you plug in the 7.3, if I have the 7.3 or the 4.2, it doesn't matter which one we use. If we plug it back in to solve for W, we'll get the other answer. So the dimensions are 7.3 by 4.2. And that would be in inches. Part B, find the dimensions of a rectangle if the length is 1 more than twice the width and the area is 55 meters squared. So if we have a rectangle and the length is 1 more than twice the width. So if I call the width x, the length is 1 more than twice the width. So it'd be 2x plus 1. So the area is 55 meters squared, so x times 2x plus 1 is 55. So if I distribute this x, I'll have 2x squared plus x equals 55. And I'm going to subtract over the 55. So I have 2x squared plus x minus 55 equals 0. And I'm going to try the slip and slide here. So if I move the 2 over, I'll have x squared plus x minus 110. And are there factors of negative 110 that add up to positive 1? Yes, there are. We have x plus 11 and x minus 10. 11 times negative 10 is negative 110, and 11 plus negative 10 is positive 1. So if I solve for x, I'll get x equals negative 11 and x equals 10. But if we were to plug those back in, thinking that this is the dimensions of a rectangle, we would have a length of negative 11 if we chose this one, so we cannot include that one. Therefore, we need x equal to be 10. So if x is 10, then for the width, then the length is 2 times 10 plus 1, which is 21. So I have a rectangle that is a 10 by 21. And then now part C. If one leg of a right triangle is 3 less than the other leg, and the area of the right triangle is 14 centimeters squared, 14 square centimeters, find the length of each leg. So I'm going to draw a picture here. Here's my triangle. So if we have one of the legs and the other one is 3 less than the first one, and we know the area is 14, well, the area of a triangle is 1/2 base times height. So I'll have 1/2 times my base, which is x minus 3, and my height, which is x, or either way. So then we'll get that is equal to 14. So if I have 1/2 times, if I multiply this x in, so I have x times x minus 3, x squared minus 3x equal to 14. If I multiply both sides by 2, I'll get x squared minus 3x equals 28. And then if I subtract 28, so I get x squared minus 3x minus 28 equals 0. That factors into x minus 7 and x plus 4. So that tells me that x is equal to 7 or x is equal to -4. But I cannot have a leg with a length of -4. So x is equal to 7. So if I plug that in, I'll have this side equal to 7 and this side will be equal to 4. So this is a 7 centimeters by 4 centimeters. Actually, let's not use the words by. That doesn't make sense. So let's not use that word. Let's use 7 centimeters and 4 centimeters. Okay. Now for the next part. How many real solutions does each quadratic have? So for these, we can just look at the discriminant, which is b squared minus 4ac. So here we would have, for b squared, we'd have 9 minus 4 times a, which is 2, times c, which is -7. So we get 9, that multiplies to positive 56. So then that would be equal to 65. So because it's positive, that means we have 2 real solutions. For this one, first we need to put it into standard form. So b squared is 4 minus 4 times a, which is 3, times c, which is 6. I don't need the equals 0. Okay. So b squared minus 4ac, here that equals -68. And whenever it's negative, that means we have no real solutions. And remember, think about that discriminant being underneath the radical, the square root in the quadratic formula. If it were negative, that means we'd have an I, so it'd end up being an imaginary, not real. Okay, now for part C. 9x squared plus 6x equals -1. So I'm going to put this into standard form. So I have 9x squared plus 6x plus 1 equals to 0. So b squared is 36 minus 4 times a, which is 9, times c, which is 1. So 36 minus 9 times 4 is 36, so that gives us 0. If that is 0, that means we only have one real solution. Okay, the next part, what value of c would make the trinomial a perfect square trinomial? In other words, we would be able to factor this into x minus half of 6 is 3 squared. So if I were to multiply that out, that would give me a value of c. So if you're trying to figure out what c is equal to, take the middle term, divide it by 2, and square it. Do b over 2 squared, which is the formula we use for completing the square. So here, b is negative 6, so divide it by 2 and square it, and we'll get a c value of 9. For this one, we need to, anytime we did completing the square, we needed to get out the 4. The value of a factored out, so we'll have 4 times x squared minus 5x. So now we have plus c divided by 4. Okay, so if we do b over 2 squared here, so if we have negative 5 divided by 2 squared, that's 25 over 4. But remember that that is for c over 4. So if 25 over 4 is c over 4, then c is equal to 25. And then finally part C. Again, here a is equal to 1, so we don't have to worry about that. But b over 2, so 26 divided by 2 squared. So that's 13 squared, which is equal to 169. Now we have state the discriminant and the number and type of solutions for each. So for this part we're going to use the discriminant as well, which again is b squared minus 4ac. So if we have x squared minus 4x equals 12, so I'm going to move this all over, so I have x squared minus 4x minus 12 equals 0. So b squared is negative 4 squared, which is 16, minus 4 times a, which is 1, times c, which is negative 12. That is equal to 16 plus 48, which is 64. So there's the discriminant. And because it is positive, it's greater than 0, that means we have 2 real solutions. For part B, b squared minus 4ac, so if I have b squared is negative 12 squared, so that's 144, minus 4 times a, which is 4, times c, which is 9. So that's 144 minus, that's equal to 144 as well, so we get 0. So the discriminant is 0, and because it is equal to 0, that means we have 1 real solution. And then finally c, first put it into standard form, so we have 2x squared plus 5x plus 7 equal to 0. So b squared is 5 squared, which is 25, minus 4 times a, which is 2, times c, which is 7. So you get 25 minus 56, and that is equal to negative 31. So that means we have 2 non-real complex solutions. Wrong spot.